In section 4.2, we learned the rules for writing the formulas for covalent compounds and also naming covalent compounds. The type of covalent compounds that we're going to write to learn the formulas and names for are what are referred to as binary covalent compounds. And a binary covalent compound is simply a compound in which only two types of atoms are present. So, NO2 is a binary compound because it contains only nitrogen and oxygen atoms. This would also be a covalent compound because it is formed between non-metals. NaCl is a binary compound because it's composed of only sodium and chlorine atoms. However, it would be an ionic binary compound because it contains a metal bonded to a non-metal. So, what we're concerned with in this section are binary molecular compounds, which are compounds formed between two non-metal atoms. So examples would be H2O, P4O10, N2O4, H2O again, N2O4 again, P2O5, P4O10 again, and SO3. All of those circled compound, or all of those compounds that I just circled, would be considered binary molecular compounds. When we write the formula for a binary molecular compound, we write the atoms in the approximate order of increasing metallic character. So just remember that the elements become more metallic as we head towards the bottom left of the periodic table. What this in reality means is that we're normally going to write the lowest group number element first, and if the elements are in the same group, we're going to write the one that is lower down in that group first. There are a couple of exceptions to this general trend. We write hydrogen, which is in group 1A, before those elements that are in group 6A and group 7A, but after those elements that are in group 3A, 4A, and 5A, and then we write oxygen and fluorine at the end of our molecule. So you can see here we're going to write in order of lowest group number to highest group number, but if the elements are in the same group, we write from lower down in the group to higher up in the group. So iodine right at the bottom of group 7A, then bromine, then chlorine. So we kind of write them going up the group. Okay, so that's how we write formulas. Lowest group number first, highest group number last. Hydrogen comes before group 6A and 7A, but after group 5A, and then oxygen and fluorine are at the end. Now, when two metals combine to form a binary covalent compound, the rules for naming such compounds are pretty easy. We give the name of the first element in the formula unaltered, so just how it appears in the periodic table. But the second element, we give its root name, which is normally the first syllable, and then we finish it off with the letters I, D, E. We then go in and add Greek prefixes, which are numerical prefixes, to indicate the number of each atom of each element that are present. So I'll show you what I mean. The first thing we're going to have to do is memorize the Greek numerical prefixes between 1 and 10, and we don't use 1 very often, and we'll make a note of that as we move through. I always say that memorizing these is not a total waste of time. You can impress friends at parties. I just drank a hexapack. Sounds quite sophisticated. So here's a little rule about mono. If there's one of the first prefix, or one of the first elements, you don't give it a prefix. So rather than saying monocarbon disulfide, we just say carbon disulfide. rather than saying monocarbon dioxide, we just say carbon dioxide. Now this is an interesting one. We don't say monocarbon monoxide, we say carbon monoxide. Again, we don't say monophosphorus pentachloride, we just say phosphorus pentachloride, and so forth. And you'll see that the formula and the name follow the same sequence of elements. In each case, we write the name of the first element unaltered. We change the ending of the second element to IDE, and where appropriate, we add the required numerical prefix. This is an interesting one. If hydrogen is the first nonmetal listed in the formula, we're going to name it as though it was an ionic compound, which basically means that we're not going to put in any Greek prefixes. So, rather than writing hydrogen monochloride, we're going to drop the mono and just call it hydrogen chloride. Rather than writing hydrogen monofluoride, we're just going to call it hydrogen fluoride. Rather than saying dihydrogen monosulfide, we're just going to call it hydrogen sulfide and omit the prefixes. So, a little bit of care to understand the exceptions and we should be okay. So it says write the molecular formula for each compound. So the first thing I'm going to do is I'm going to write the name of the first element in each case. So we want the formula, we're not writing the name, we're turning the name into the formula. I'm going to write the symbol for the first element in each case. There we go. So we have nitrogen, oxygen, sulfur, and selenium. Now all of these, there's only one of them because there's no prefix, with the exception of oxygen where there is two of them. Now I'm going to move on to the second element, and it says oxide, fluoride, fluoride again, and then oxide again. And now we have to add in prefixes where appropriate. So there is 2 oxygens, 2 fluorines, 6 fluorines, and mono means there's only 1 oxygen, and we never add a prefix for 1. So that's pretty straightforward, taking a name and turning it into a formula. This is going back the other way. We're going to take a formula and we're going to turn it into a name. So I'm going to write the first element unaltered, and then the second element, I'm going to take the first syllable and add the ending. Probably should give myself a little bit of space here. I'm going to take the first syllable and give the ending IDE. So fluorine becomes fluoride, chlorine becomes chloride, and oxygen becomes oxide. And now we're going to add in our prefixes. None of them need a prefix for the first element because there's only one of them. There's 4 fluorines, so we're going to call that guy tetra. There are 2 chlorines, so we're going to call that di. And there are 3 oxygens, so we're going to call that tri. So we end up with carbon tetrafluoride, selenium dichloride, and sulfur trioxide. Okay, so a little term to be mindful of is the term empirical formula. And the empirical formula of a compound is the smallest whole number ratio of the elements present in a compound. This might not be the same as the molecular formula, so you do have to be careful as to whether what you're being asked for is the empirical formula or the molecular formula. For example, hydrogen peroxide has the molecular formula H2O2. However, the empirical formula for this compound is simply HO. Now, sometimes the empirical formula and the molecular formula are the same. For example, H2O, it's not possible to simplify this formula, so therefore H2O is the molecular formula as well as the empirical formula. So you should be mindful that the empirical formula of a molecular compound, it's always a whole number multiple. Actually, that's the wrong way around. The molecular formula of a molecular compound is always a whole number multiple of the empirical formula. And the equation down here expresses that correctly. The molecular formula is always equal to a whole number times by the empirical formula. So you can see that here we have dinitrogen tetrafluoride. This would be the molecular formula. This would be the empirical formula. And you can see if we take the empirical formula and times it by 2, we get the molecular formula. Hydrogen peroxide has the molecular formula H2O2. It has the empirical formula HO, and you can see if you multiply the empirical formula by a factor of 2, you get the molecular formula. Methane has a molecular formula CH4. That can't be simplified, so CH4 is also the empirical formula. So if you take one lots of the empirical formula, you get the molecular formula. Benzene has molecular formula C6H6, which means its empirical formula is CH, and if you multiply the empirical formula by 6, you get the molecular formula. Okay, so that concludes our section on formulas and names of covalent compounds.